Hello, class. It's been a long time, and good morning. Um, Finally, am doing the video. I know it's been long overdue, but with all the crazy things happening all around us, the first thing I wanted to do was just get used to the whole system and make sure that whatever I'm making is on point and precise. And I know that I'm supposed to give you a video lesson every day, but sometimes I know that I give you a practice problems on the side or whatever that I feel that you guys need to do on Pearson. So, but for today, I want to make sure that I go through with you guys on this in more detail. The past 2 days or past 3 days for that matter, it's all been about volumes of 3D shapes of pyramids and cones and etc. And I don't really want to go over that with you guys, particularly because I felt that you guys could study that on your own and it's just formulas and those kind of things. For today, the triangle inequality and Cavalier's principle. It's a little bit more elaborate, so I want us to study this together. Keep a couple things in mind. For next week, I will give you a test. So the test will be incorporating everything from circles only. Now these topics that I'm teaching you guys is just going to be for the sake of doing something in terms of teaching the like, new stuff. But this will not be on the test. The only thing that will be on the test would be inscribed angles in a circle. So I will make sure that I have a review materials for you guys over the weekend to have. But this is just extra stuff that I'm going to teach you for today. So for today, just work on this. And I'll give you the review packet on Google Classroom so that you guys can work on it. And we'll go over it next Monday and Tuesday. We will be just reviewing. And then the following day on Wednesday, I will give you the test. Now remember, if it's my test, you guys know that you guys are supposed to pick the questions and whatnot, and you guys are supposed to be making sure that you guys are answering every questions, getting the best points, and hopefully this will do less damage from the benchmark grades that we have gotten. Okay. All right, so today the main topic is going to be triangle inequality. Once I'm done with this topic, then you guys just feel free to work on your homework, and then that's going to be it for today. So let's go over some triangle inequality. Cavalier's principle, we're going to put that on hold because it's going to take some time for us to get used to that. But this is the part of the volume chapter that we have been dealing with for the past 2 days. But it's really simple concept, but I want to teach you guys that once the time arrives. But just worry about triangle inequality for today. So let's take a look at some of these questions here. Now I will upload the slides for you as well on Google Classroom for you to see, so that you guys can get used to what we're going to be eventually be getting into. Now decide whether each set of numbers is a triangle. Now this is the homework problem that you're going to be seeing. If I go to here, these were your homework questions, okay? So I'll also show you guys how to do certain questions like these. And the concept is very, very simple. Now, for something like this, I want you guys to think about the formula, and this is how it's going to be. You are going to pick the largest side of a triangle, and you're simply going to add the other two, which is 12 plus 9, which gives you 21. Now, for anything, if that number is not bigger than 15, you're not going to have a triangle. Luckily, I do. So if I were to call this your two smaller lengths, okay, that those two added together has to be bigger than the third side or the largest side. That's for a fact. Now here's an example of what's going to happen if you don't have that situation. That's exactly like number 2. Okay, so I'm going to do this, and I'm going to just show you guys number 2. Let's just focus on number 2 for now. If you were to take a look at these 3 sides, notice that one of the length is 2, the other length is 1 and 1. Now, if you were to put these 3 things together, okay, where this is 2 and this is 1, you are going to have an incomplete triangle. Like there's going to be this little gap here. Like you won't be able to fill the gap, because if you think about it, the only way that these three lines, 2, 1, and 1, will be all connected is if they were all in one singular line, because that's 2, that's 1, and that's 1. It's going to look like this, essentially, like a bolded line. That's not a triangle, okay? It's just triangles squashed in so closely together that it literally resembles a line. So the answer to the second question would simply be a no, and that's pretty much going to be it. Going back to this problem, this will resemble a triangle because I know for a fact that 12 plus 9 is bigger than 15. Now, there is another thing that you also must consider then. Now, let's just suppose that we want to find out that the length of the largest side, or actually, wait a minute. This is only whether you're deciding whether each set of numbers is a triangle. I believe this is the question answer to. No, that's not the answer to that. So I believe the answer to the first question here, decide whether each set of numbers is a triangle. This is just going to simply be a yes situation, because the greater two sides have to be bigger than the last side, or the largest side. Now for this one, again, if you were to do this, if I were to ask you to do this, what would you do? Decide whether each set of numbers is a triangle. You can pause the video right now and then try to do this on your own. Now, I'm going to go over the answers now. The answer to this question would simply be a no. Why? Well, it's because if you pick the largest side, and if you add the other two, 16 plus 7 becomes 23. Now, 23 is not bigger than 23. Therefore, it can't happen. So this is going to be a simply no. It's one of those where it was just 2, 1, and 1, the example that I just showed you. And so that's not going to be a triangle. Okay? Now, for the last part for today, because this topic is relatively short, determine the range of values in which it makes it a triangle. These questions, what you will see is that you will always have these two values, and they're going to ask you for a range of something. Well, range is, lowest to highest, they give you an interval and that kind of thing. And the way that you do these problems is that you want to make sure that you add the two and then you subtract the two. And here's the reason why. For number 5, for example, let's say that I want to find the range. Let's say that the third side length is x. So that means that 28 plus x has to be greater than 47, because, like we established before, when you add these two together, it has to be bigger than the largest side, assuming that this is your largest side. Okay? That is one situation. Now, the other situation would be if you were to consider the x to be the largest side. Then what would happen then? Well, if that's the case, that means that this 47 plus 28, these two added together, has to be bigger than x, because if these two is not greater, then we're going to run into a situation like the one we did before. And if we have something like this, where the sum of the other two is less, so for example, if it's something like less, imagine what would happen visually. 24 is this, 16 is this, and then like 7 is going to be like that. The only highest possible way that you can make up this, connect this to this, is where you have this as 24, you literally connect from here to here, then that's 16, and from here to here, again, that's 7, and you're still short. Like, that just simply cannot happen. So, if I were to give you a stick of 24, and then 16, and then 7, there is no possible way in which you guys can make a triangle, because they're not going to meet up. And it's going to pretty much look like this. So, These two are your situations. Now, what happens in this equation right here? I'm going to use a different color for this. What happens in this equation right here is that you have to subtract the 28 on both sides. And what ends up happening is x is greater than 47 minus 28. And then 47 is less, the x is less than 47 plus 28. So if you were to take a look at all of these things that just happened, what you're essentially doing is that you're adding them together and then you're subtracting them together, just like how you have done it here and here. Okay? So, how do we do this a lot quickly? Let's do number 6, okay? And so I'm going to call this x. The way that you find the interval, the range of the values in which it makes a triangle, is if x is right in the middle and you open these little interval, crocodile's mouth facing in. I like to usually, make it open towards from left to right. So this would be your smallest possible length, and this would be your largest possible length. And the way that we have done it before is that we have found the 47 plus 28 to be bigger than x. Bigger than x. So what I'm going to do is I'm going to take the 41 and add it to 28, which gives you 69. So 69 will be your largest side. Just also, it's bigger than x. Just like how this one, 47 plus 28, was bigger. Now the other part, the smallest part, really comes from there. 47 minus 28, which becomes 19, of course. And the smallest length possible between these two, 28 and 41, it's going to be 19. Because if x was indeed 19, and when you add 28 and 19 together, it becomes 41. And 41 and 41, well, that's not a triangle, right? So x has to be bigger than 19. It cannot equal to, okay, that's a huge mistake. It cannot be equal to. It has to be at least bigger than 19, starting from 19.1. Then it's going to work. Okay, so that is going to be your range of triangle inequality. So for the 7 and 8, you can pause the video right now and try it yourself. Okay, so you're playing it back again, so which means you better have the answers ready for me, guys. Okay, so the answer for this one will be x is bigger than 5 and is bigger than 15, and x is bigger than 31 and less than 49. These will be the answers, how to do these questions. Okay? All right, so if you go back to the homework page that I've just shared with you, can these numbers be the lengths of the sides of a triangle? So please show the math to prove your answer. And triangle inequality theorem, the sum of the lengths of any two sides of a triangle is greater, less, or equal to. Pick out of those three choices. And exercise 10 through 15 is pretty much the same thing as what we have done in the last slide, which is the following. Could be the length of YZ. That's a multiple choice question. And try number 17, it's pretty much the same thing. You have to draw the picture, please. If it's a word problem, please draw the picture first and make sure you can do this using the triangle inequality theorem. Okay, so I think this was the good, just summary of what I wanted to do today. Hopefully, the coronavirus outbreak, it all dies down, but you guys all know that, the numbers are only multiplying. I think it's about 700 people today. I don't know. I'm not sure how many more people has been infected in just the state of New Jersey. Please stay safe out there, and let me know if you have any questions. Remember, next week, March 27, is the last day of the marking period. So if you don't like anything that you see on the grade book, you have to let me know through email. I'll be more proactive with emails and things like that. So please, if you send it to me, I'll be able to help you. And thank you. Finish the homework by the end of today. And I'll see you guys sometime later in the future. Bye-bye.